question B, we're asked to solve the function 4 cos squared theta minus cos theta equals 2 sine squared theta. The standard identity that we'll need to use here is, of course, sine squared theta plus cos squared theta is equal to 1. And in this case, because we already have a cos squared and a cos theta, I'm going to remove the sine squared. So in rearranging, we get sine squared theta is actually equal to 1 minus cos squared theta. Substituting this into our expression, we're going to end up with 4 cos squared theta minus cos theta is equal to 2 lots of 1 minus cos squared theta. Expanding out, we can see then that all our terms are in cos, so we can then rearrange this to create a quadratic equation in cos, which will help eventually simplify. So in rearranging, we're going to end up with 6 cos squared theta minus cos theta minus 2 is equal to 0. Now, in most cases, this will factorise immediately into 2 brackets using our standard methods for factorisation. In this case, 2 numbers that multiply together to make minus 2 can only be minus 2 and 1, so that's a bit of a help as a starter. And then by a little bit of trial and improvement, you can see that the cos functions will be 3 cos theta and 2 cos theta plus 1. Expanding that out to check will give you the function that we've just factorised. Once we have this situation now, we can find 2 values for which will work for cos theta. In this case, the first bracket, cos theta can equal 2/3, and in this bracket here, cos theta can equal minus 1/2. Both of these values will make the function equal to 0. First of all, examining cos theta is equal to 2/3. Doing our standard calculation on our calculator, you'll find one value of theta to be 48.19 degrees. It's helpful here to just draw a quick sketch of a cos graph, just to remind yourselves of the periodicity of the graph. So we have 360 degrees here, 270, 180 and 90. And we can see here that 48.19 degrees lies approximately here. We have a second value, which due to the symmetry of the graph would be 48.19 degrees back from 360. So giving our next value to satisfy that equation is 311.81. Cos theta equals minus 1/2. Our first value has come from calculation, which should give you a value of 120 degrees. Obviously this lies approximately here, and from the symmetry of the graph we can see we'll have another value here which is 120 degrees back from 360, giving our other value of 240 degrees. It's always a good method to draw the cosine wave or the sine wave or the tan wave when you're solving these equations, to give the examiner an idea of your understanding of the question.